Question number 1, we have a cyclic quadrilateral. And in a cyclic quadrilateral, the opposite angles are supplementary. So if we're finding the measurement of this angle over here, all we need to know is that it's supplementary with this one over here. And then we can do 180 minus 72. And we find that this one over here is 108. And I'm going to write that down. 180 minus 72 equals 108 degrees. Opposite angles of a cyclic quadrilateral are supplementary. Okay. For the next one, we need two things to write the equation of a circle. We need the center and we need the radius. Remember, the center is h comma k and the radius is r squared. So the center of the circle is the point right over here, -1, -2, -3, 1. So remember, the equation is going to have opposite signs from what the center has because of the built-in negatives. So if the center is -3, 1, then I'm going to be looking for an equation that has +3 and -1. So answer choice is 1 and answer choice is 3. Answer choice 1. Yeah, and answer choice 3 I can automatically eliminate because I know that the coordinates in the equation are going to have to be x plus 3 squared and y minus 1 squared. So that leaves me with just answer choice 2 and answer choice 4. So the last thing I have to compare is the radius in order to figure out which is the correct equation. So in order to figure out the radius, I am going to have to actually find the radius. So I'm going to do from the center to a point on the circle, and I want to do a clear point. This way, this is not a clear point. This is not a clear point. This is not a clear point. So I want to look for a clear point, and any clear point will be fine. I'll go with this one right over here. And that's the point -1, 1, 2, 3, 4. And I can see that that is on the circle. Ooh, that's really thick. Let me get a thinner line for that. Okay. And actually, what I'll do instead of using the distance formula is I'll just use Pythagorean theorem to find the length of the line. 2, 3, 2 squared plus 3 squared equals to c squared. 4 plus 9 equals to c squared. 13 equals to c squared. C equals radical 13. So the radius is radical 13. You could have used the distance formula instead to find it, but I had the graph, so why not use Pythagorean theorem? So for radical 13, that is the radius. But remember, in the equation on the right-hand side, it's r squared. So r squared is radical 13 squared, which is just 13. So that would be answer choice number 4. That would be the correct answer. Okay. We have parallel chords, AB and CD. And we know that parallel chords intercept congruent arcs. So the arcs in between them are congruent to each other. And that means answer choice number 1 is true. So that's not the right answer choice. Let's take a look at the rest. Already, if I have parallel lines, my alternate interior angles B and C are going to be congruent because those are alternate interior angles. So 4 is true. So I'm going to put I'm going to cross out that answer choice. BE is congruent to CE. Triangle ABE is similar to triangle CDE. So triangle ABE is similar to triangle CDE because we have the congruent alternate interior angles, and we also have congruent vertical angles. So we have AA, which proves the two triangles similar. True. So that leaves us with answer choice number 2. there's no way we have of knowing that BE and CE are congruent to each other. We're not told that BC is bisected. We don't know that the triangles are congruent in order to CBCTC those segments. In fact, all we know is that the triangles are similar by AA. For the next one, all we have to do is use the Pythagorean theorem, because what we have here is we have a tangent and a radius to the circle, and they're perpendicular. So that means that they form a right angle where they intersect, because perpendicular lines form right angles. So the only tricky part is that this side over here is composed of the 4 and the r part over here. So we can represent it as 4 plus r. So what I'm going to do over here is I'm going to plug into the Pythagorean theorem. So a squared plus b squared is equal to c squared. And if you're going to multiply 4 plus r squared, just recognize that that's the same as 4 plus r times 4 plus r. So you are going to have to distribute and FOIL it out. I don't want to do that. So what I'm going to do instead is I'm going to use the answer choices to help me out, because I do know it's a right triangle, and I do know that I'm looking to satisfy the Pythagorean theorem. So what I'm going to do is I'm actually just going to try in the answer choices. So 16, let's check it out. 12 squared plus 16 squared, and that should equal 20 squared. So 20 squared is 400. 12 squared is 144. 16 squared is 256. When I add them together, it does equal to 400. So it's looking like that is the correct answer. I can try out the other answer choices real quick, just to double check. I'll just try out one of the other ones. Let me try out 20. So if this is 20, then this would be 24. And this would be 20. And plugging into the Pythagorean theorem, we have 12 squared plus 20 squared equals to 24 squared. 12 squared is 144. 20 squared is 400. That's 544. And let's see what 24 squared is. 576. So those are not equal to each other. You can also try the same thing with 3 and 4, and you should find that it does not satisfy the Pythagorean theorem. Only answer choice 1 is going to satisfy the Pythagorean theorem. So I'll just put the work for that one back up really quick. Oops. Let me go back to it. There we go. We got lucky here that the first answer choice satisfied the Pythagorean theorem. Okay, we're talking about arc length in radians. So I'm going to use my formula, S equals R times theta. Remember, S means arc length. I know it's an S, don't think it means sector area, it means arc length. And remember, in order to use this formula, the angle needs to be in radians, or you need to want your angle in radians, because it will give you an angle in radians. So it tells us that the arc length is 12 pi. The diameter is 36, so that means the radius is 18, and we are looking for theta. So all I have to do is just divide both sides by 18 to get theta by itself. And 12 over 18 reduces to 2/3. So the answer is 2/3 pi, or 2 pi over 3. For the next one over here, PB is 4, BC is 5, and we need to find the length of PA. So we're looking for segment lengths of outside segments. So that's going to be whole times outside. I'll just abbreviate this out, equals whole times outside of the other. So I'm going to start with the secant. The whole is 9. the outside part is 4. And then on the tangent, the whole is x, and then the outside part is x. The whole and the outside part are completely the same. And we get x is equal to 6. It does say the length of PA, which is represented as x, so that is simply just 6. Just double check the question to make sure you don't have to plug in. Okay, for this one over here, there were multiple ways that you could have done this one. I'm just going to show it one way. So we have tangents to the circle DA and DB, and I see that tangents from the same outside point to the same circle are congruent. I also see the reflexive property over here, and I noticed that when a radius and a tangent meet, they make right angles, so I have right triangles, and that's HL. There is another way that you could have done this. Also, you could have used the fact that BO and AO are radii of the circle, and you could have said all radii are congruent of the circle, and that would give you SAS. I'm going to do it with HL. Okay, so I'm just going to write my givens. And everything I just put in the diagram, I'm going to make sure to get inside the proof. So I'm going to start with the right angles. So I'm going to say DA is perpendicular to AO. And in the same step, I'll also put that DB, the other tangent, is perpendicular to the other radius because it uses the same reason. Oops, I can't spell today. When a tangent to a circle and a radius meet, they are perpendicular. And now I'm going to state that I have right angles there. I'm just going to call it angle A and angle B because they're not split up into smaller parts. 3 other letter names are better, but I'm just going to call it by one letter name because I don't think there's any confusion there. Are right angles. And that's due to the perpendicular lines. They form right angles. Okay. Since I am using HL, I do need to say that the triangles are right triangles. So triangle ADO and triangle BDO are right triangles. A triangle with a right angle is a right triangle. I don't need to say that angle A and angle B are congruent to each other because all right angles are congruent. Because for HL, you don't need congruent angle pairs. For HL, what you need is right triangles, which we're stating, and then congruent hypotenuses and congruent legs. If you were doing SAS, then you would need, instead of step 4, your step 4 instead would be angle A is congruent to angle B because all right angles are congruent. Because for SAS, the A means that you need congruent angle pairs. So for HL, you need right triangles. For the other ones, for the A's, you need congruent angles. Okay. Let me get in. So that was all to get the right triangles. So let me get in the sides I'm using. Now let me do the hypotenuse first. So the hypotenuse is OD congruent to OD, and that's due to the reflexive property. And then let me make sure I get the leg in. So the leg is, let me look at that letter, AD, congruent to BD. And that is because tangents to a circle from the same external point are congruent. Two tangents to the same circle from the same outside point are congruent. And from there, we have everything that we need to say that the two triangles are congruent to each other. Step 7, due to HL. And then we can prove the proof statement that these two angles are congruent due to CPCTC. Oops. Okay, this one we need the area of the sector. So sector area equals to the angle over 360 times the area of the whole circle, pi r squared. So we need to find the area of the sector. The angle is 80 degrees. And the radius is 6.4. So since it does say to round to the nearest square inch, we are going to be putting pi into the calculator. So I'm going to go to my calculator and I'm going to put this whole entire thing into the calculator. Give me a moment. 80 over 360 times pi times 6.4 squared. And I got to the nearest, I got 28.595. So to the nearest square inch, that rounds up to 29. So the area of the sector is approximately 29 square inches. For this one over here, we need to circumscribe a circle around the triangle. Let me get my compass for this one. So for this one, you just need to construct perpendicular bisectors of the sides. And you don't need to do all 3 perpendicular bisectors. 2 is enough. So I'll just do for any 2 sides. And mine's not going to be super accurate because I'm on the computer. Yours will definitely be more accurate than mine. And this computer is also all freezy. Oh, that was really off. Let me try that one again. Okay. Once again, it'll be slightly off on the computer. It's pretty hard to do this on here with my frozen computer. Okay, I'm going to do another side now. I'll just do BA. The exact distance that you're opening the compass doesn't matter. It just needs to be more than 3/4 down the side. In fact, it could even be the whole way down the side. As you can see, my computer froze and messed that one up. So we'll see how accurate this one is. Hopefully it's a little bit accurate and not super far off. Let me see. It's still frozen. I click on one thing and it just goes to another. There we go. So from here, I can see the point where they intersect, and that's the circumcenter. So now to circumscribe the circle, all we have to do is put the compass onto that point and swing a circle through the vertex points. Oops. So I'm going to go on to that point, and I just want to open to any one of the vertex points. And then I'm just going to swing a circle. And it did come out pretty good.